Okay, good morning, everybody. How you doing? Good. Yeah, welcome back to class. Let's see, last week we ended up starting on the 10th of the theories regarding the frozen mammoths. And that, of course, is the hydroplate theory. And so we started to describe it, and I kind of read briefly what the hydroplate theory proposes. We got through that, but maybe I'll just kind of briefly go through it again, just so you get it kind of refreshed in your memory. Basically, on the day that the flood started and the Earth's crust ruptured and the fountains of the Great Deep, of course, opened up, the Earth's crust, the rupture in the crust, or the opening in the crack, would have passed between what is now Siberia and Alaska, and that's what had just taken a few minutes. And jetting water up through this crack would become waters that came up from the subterranean chambers below. And the tremendous amount of energy released during this would have produced a huge amount of torrential rains as this water and debris and rocks that were in the subterranean chambers were ejected high up into the atmosphere. And some of this material even went past our atmosphere out in, and as we went through previously is a explanation for the formation of comets and asteroids and trans-Neptunian objects. But the rain that would fall, that's described in Genesis 7, 11, and 12, is a special word called Geshem. And Geshem rain is basically a torrential downpour or deluge. It's a different word than used other places in the Bible for normal rain. However, it's translated as rain. But you don't really get the notion of how much more intense this rain was unless you go back and look at the original Hebrew words. But during the first few hours of the opening up of the fountains of the Great Deep, the expanding subterranean water exploded out of this opening, these cracks that eventually circled the entire Earth, and shot all this up high up into Earth's atmosphere, up very high into our atmosphere, into at least the fourth layer of our atmosphere called the thermosphere, which is about 50 miles high. And above that temperature, or in that layer of our Earth's atmosphere, temperatures can reach 150 degrees below zero or lower. And as we'll talk about today, I think we'll get it to today, some of the material would have actually gone out beyond our atmosphere and out into outer space where temperatures are even colder. But the Earth's gravitational pull would have still had an influence to pull this back down to Earth, where it would rain down on the Earth as this tremendous rain. And because of the yes, well, you can hear me out there, right? I think we're okay. As this material fell back down toward Earth, it would have frozen and would become the hail, and the frozen hail that would have contained large amounts of sediments and rocks, and would be the sources that would produce the frozen muck. And because they were super cooled, well below normal freezing, they would blanket down vast areas and would have quickly suffocated and buried mammoths during the process and preserved them. So that's kind of the basics of the hydroplate theory. So now we're going to take a little bit more of a deeper look into this. Here's the chart again that Dr. Brown uses in the book. And as you'll see, virtually every evidence that we're trying to explain, it has a green light in it. So it means that it adequately does explain this particular feature. One of them in yellow here is the summer-fall deaths, and I think as we get into this, you'll find out that that isn't really even a factor. So let's go through these kind of one by one and go through some of these evidences here. So as we discussed earlier, winter sunlight inside the Arctic Circle is so scarce that vegetation hardly grows there, regardless of the temperatures. So how could mammoths survive even during a warm winter there? And clearly mammoths didn't. They were living in temperate conditions before the flood. So discover why this is the case and why it would be important. I think it's important here to discuss in greater detail now the pre-flood Earth versus today's Earth conditions. Remember, these mammoths lived pre-flood. Okay, they were buried as a result of the flood. So their conditions that they were living in right before they were buried were pre-flood conditions. So to completely understand this, I think we need to go back to one of the minor assumptions of hydroplate theory, and one of the pre-floods Earth initial created conditions. So one very important item to remember is that there's various evidences that we're explaining is that Earth is prior to the Great Flood. And again, it's greatly different than our Earth conditions are today. And you may recall, as we discussed this earlier, that the initial conditions were that there was a pre-flood crust that circled the Earth with waters above that crust and waters below the crust. This again was described in Genesis 6, Genesis 1, verses 6 through 10. And so what would have happened on day 3 of creation is depressions in that crust with the water below and the water above would have allowed waters to drain into those depressions and would have created an arrangement similar to, I think, what you see here. Now this is again just a representation. We don't really know exactly how this is going to look, but we would see, I think, that there's really just one great continent that was over the whole Earth with many seas in that one continent, rather than the 7 continents that we see today. So the pre-flood continent here, as we're showing, is in green, and the pre-flood seas are shown in blue. And then I've got some blue lines representing the pre-flood rivers. We knew there were rivers that were created during creation as well. And again, this is just a guess, but I think this is a pretty good guess of what the Earth's arrangement would have been. So there's relatively shallow seas that formed during day 3 of creation. There were maybe some large seas, but no oceans anywhere near the size of the Atlantic or the Pacific Ocean. And we'll see later how oceans of that size formed as a result of the flood. But for now, just realize, I think this is a pretty good representation of what the pre-flood Earth would have looked like. Also, mountains of the pre-flood Earth would have been much lower than the mountains we have today. Some pre-flood mountains would perhaps be as high as a mile above the pre-flood seas, or pre-flood sea level, or not the many miles of height that we see with the major mountains today. So today, as you may remember, Dr. Brown estimated that the pre-flood subterranean chambers was about a mile thick. So we had water perhaps a mile thick on the crust, on the surface on day 2. We had the 60 miles or so of this crust, and then about a mile of water below that crust. So on day 2 of creation, I think this is basically the arrangement. On day 3, recall that it says land rose up out of the surface of the water. And this was, of course, in preparation of God then going on to create plants and animals and humans during the next 3 days of creation week. But on day 3, what seems to have happened is the crust deforms because of some irregularities in the crust density, and would have depressed and sank down to touch the mantle below the crust, and would have touched that mantle and perhaps hundreds of different places around the Earth, forming pillars that are referred to in some of the passages we talked to actually earlier. So logically, if you think about this, with a mile thickness of waters below the subterranean chambers, you would think that the mountains that were created, or the high spots, couldn't logically be higher than maybe about a mile. I mean, that's about as far as they would go. So in other words, if the crust depresses a mile or so, waters drain into that. Other areas now appear to have risen out of the water. However, they would have been maybe only a mile or so high. They couldn't really have gone much higher than that. Today, however, our mountains are much, much higher than that, or somewhere. Now, Mount Everest is the highest mountain on the Earth, on the world today, and it rises up about 5.5 miles above sea level, so dramatically higher than that. So obviously something dramatic happened to raise many mountains that are much higher than a mile above sea level, and we'll see later on how that occurred as a result of the flood as well. So during the continental drift phase, which we'll talk about, as these plates that were sliding away from each other ran into resistance, they would horizontally been compressed because of their motion and push mountains up very rapidly and cause dramatic rising up of mountains. So again, this is a result of what Dr. Brown has called a compression event. And so we'll talk about that more when we get to those phases of the flood. So what this means is the pre-flood Earth, much of the Earth's water, roughly about half of it, remains trapped under the crust until the time of the flood. So only about half of the Earth's water that we see today was actually on the surface. We can only speculate on this, of course, but given that so much of the Earth's waters were trapped below the surface or under the rakia, or the expanse, it was cut off from the surface and would not mix with the surface waters until the fountains of the Great Deep burst forth. And at that, the pre-flood mountains were, again, I think only a mile or so high or less. And we can also roughly estimate, too, that the Earth's land surface would have been something around maybe 70 to around maybe 85% or so of the total surface area of the Earth. So if we took all the surface area of the Earth, about 15 to 30% of that surface area would have been the seas, would have been covered by the seas. And I think around 70 or 85% would have been covered by, land. So there's a lot more land. Today, the reverse is true. Today, we have around 70% of the Earth's surface is covered by oceans or waters, with only about 30% of our current Earth being land areas. So again, these pre-flood seas would have been much smaller and shallower. And with the surface having much shorter mountains we see today, the topography would have been much, much different than we have today. This makes a passage that's found in a book called 2nd Esdras very interesting and really amazing. Now, the books of 1st and 2nd Esdras are texts from what's called the Biblical Apocrypha. It's a collection of ancient books that are not generally accepted as official scripture, and that's why they don't appear in our Bibles today. But they do appear in some Bibles. They appear in a Greek Orthodox, Episcopal, and some Lutheran Bibles. And though not in the Bibles we use and accept as official scripture, they do contain some really interesting and amazing passages. This passage comes from the book of 2nd Esdras, and this was attributed to have been written by the scribe named Ezra. And so this passage reads, "On the second day you created the angel of the firmament and commanded him to make a dividing barrier between the waters, with one part withdrawing upwards and the other remaining below." And that sounds just like hydroplate theory, right? I mean, it sounds like there's part of the water above and part of the water below. And then it goes on to say, on the third day, which is when land appears, you ordered the waters to collect in a seventh part of the earth. The other 6 parts you made into dry land. And so there's some emphasis added here to kind of point that out. And although scripture, this is not scripture, this describes what could have been the topography of the surface of the earth after the third day. So here it describes dividing the surface of the earth into 7 parts, 1/7 being the seas, and 6/7 of the Earth's surface being the land areas. So if we do the math and we divide that out, that's about 15%. So about 15% were the oceans or the pre-flood seas, with 85% being land. Again, this is just speculation. This isn't considered scripture, so take it with a grain of salt there. But I think it's a good, it's an interesting passage, put it that way. So, because Earth's topography also is much smoother than today, the pre-flood rivers would have flowed much more slowly. They would have never flooded, and they would require less water condensation to keep them filled. And pre-flood mountains, of course, still existed, but we didn't have mountains like the Rockies or the Andes or the Himalayas. I mean, those are totally different mountains than what would have been pre-flood. Also, there were no volcanoes, glaciers, or polar ice caps before the flood. And the pre-flood Earth, again, had greater land area because so much water was below the crust, and the Earth's radius also would have been slightly larger. And this was because much water, rocks, and debris was ejected out out past into outer space when the fountains of the great deep burst forth. So some of this material went out in outer space and actually decreased the physical size of the Earth. Yes?
Assume before the flood there was no rain on the Earth at
Yeah.
that time.
Yeah, well, we speculate on that, but I think there was no rain. We'll go through that in just a little bit here too. So all this material that got ejected out was a small percentage of the Earth, but a reasonable amount of material when you look at how big the Earth is. And so the Earth's radius would have been slightly bigger prior to the flood. So again, removing this mass from the Earth, again, small percentage, but so the Earth's radius and diameter was slightly larger before the flood, and without major barriers that we have today of the oceans and mountain chains and glaciers, travel around the globe would have been easier, and this now allows humans to accomplish what God had instructed the first humans to do. In Genesis 1:28, it says, "Be fruitful and increase in number, fill the earth and subdue it." So this allowed now travel around the earth to be rather simple. I don't think God would put barriers in their way, put it that way. Same thing with the animals too. This allowed the animals to fill the earth as well. And so with so much water condensation, pre-flood forests would have been abundant and lush. And there would have been so much vegetation that when the flood happens and a lot of this vegetation gets buried in the sedimentary layers, it accounts for our vast coal and oil deposits and methane deposits. Again, we'll talk about that a little bit later on. And then this left very little room for deserts. I mean, we live in a desert, right? But you'd think that the earth would have been much more lush all the way around. And as you'll see, the pre-flood conditions prevented rain, but abundantly watered a thirsty earth. So again, we're speculating about the rain thing, but I don't think there was rain prior to the flood. So we remember that Genesis 2:6 tells us that a mist rose from the earth and watered the whole surface of the ground. And so a subtle message here in this passage is that the watering of the earth by a mist was a steady and a routine occurrence. This would have occurred because there would have been vast amounts of heat in the subterranean chambers, these waters, which would, as we discussed earlier, have become supercritical, would have become extremely hot under an extreme amount of pressure. And this heat would have transferred into the crust and eventually would have reached the surface to warm the surface, to allow groundwater to evaporate and then condense and fall as heavy dew, providing the pre-flood water cycle. So this would have provided moisture to the vast amount of vegetation pre-flood to the pre-flood earth. Also realize that most wind is produced by atmospheric temperature differences. But because there's not the high mountains that we have today, and recall as higher up you go into the mountains, the cooler it becomes, that temperature differences wouldn't have been quite as much. So it wouldn't have produced the winds that we have now. These various, when wind mixes with air at different temperatures and continents is what causes wind to happen. So these various mixtures cause our weather that we experience today. So today we experience rain, snow, hail, hurricanes, tornadoes, droughts, along with fair weather occasionally, right? But that would have been drastically different before major changes to the Earth's topography. Okay, talk about climate change, okay? Climate change is a hot topic. We'll talk about this later on in the class too. This is the major cause of, talk about, climate change. This would have been the cause of climate change. Of course, most that advocate climate change are totally unaware of this. Also realize too that extreme weather is occasionally very harmful to us as humans. So when we see tornadoes and we see hurricanes and tsunamis and tidal waves, all things that are generated because of extreme weather, that wouldn't have been expected because of God's declaration at the end of the creation week that everything was very good, exceptionally good. Therefore, it shouldn't have been harmful to humans. Also, before the flood, the Earth would have had no polar ice and no snow-capped mountains. So less radiation of the sun would have been reflected back out into space, and with more of the sun's rays available, it would have heated the Earth more during the day. So with more forests and few, if any, clouds, and slightly longer days, the sun evaporated more water than today, and the mist rising from the pre-flood Earth kept relatively high humidity levels. And again, without the vast oceans, there would not have been all these volcanoes and things and ice sheets, meaning that the pre-flood Earth would have had a much more uniform temperature over the whole Earth. So we wouldn't have had these major swings of temperature changes that we have now. I mean, today we talked about the lowest temperatures ever recorded were in the minus 127 degree range, below zero. The hottest that's been recorded, I think, was in Death Valley. It's 130 something degrees, if memory serves me properly. But those extremes wouldn't have happened pre-flood. So the Earth would have been much more abundantly and uniformly watered than even rainfall does today. And again, the more uniform temperatures meant less wind and fewer weather extremes. So this would mean the Earth's surface would have much more temperate, would have been much more temperate, and would have had a much higher amount of vegetation across the Earth's surface. And this would allow for massive amounts of vegetation to grow, and also for animals and us to live over a much greater amount of the Earth's surface than we do today. And that's not to say that there weren't seasons prior to the flood. It's clear that there were separate seasons right from the beginning, and this was stated in the creation week in Genesis 1:14. It states that people would be able to see the stars. And one of the purposes is that they would serve as signs and seasons for the days and years. So we'd be able to tell from this information the number of days in a year, for example. And there's good reason to think that the Earth only had 360 days per year instead of the current 364.25 prior to the flood. And we'll get into that a little bit more later as well. But today, of course, the Earth has 4 distinctly separate seasons. We have spring, summer, fall, and winter. And the variation between these seasons can at times be quite dramatic, depending, of course, where you're at on Earth. And today, the seasons are caused by the tilt of the Earth's axis as it travels around the sun, and our planet leans at an angle of about 23.5 degrees. And as the Earth moves on this yearly path, different parts get varying amounts of direct sunlight. And we can't know for sure, of course, the amount of the angle of the Earth's tilt prior to the flood, but we'll see that there is very good evidence that the Earth did roll to its present orientation because of the flood. But for several reasons, the pre-flood seasons would have not been nearly as extreme in temperatures as they are today. Today we have droughts and local floods, but this wouldn't have been the case before the flood. Again, as we talked about, there would have been much greater amounts of the Earth's surface that would be able to support life, support habitation. Examining the Earth today, there's a very large amount of the Earth's surface that really isn't suited for human habitation. Today, only about 21% of the Earth's land surfaces are free enough of vast sheets of ice or uninhabitable mountain regions or maybe extreme deserts where people can actually live and grow food. But the pre-floods Earth surfaces, land surfaces, would have been able, I think, to support much more human habitation, maybe virtually over all, if not most, of the land surfaces. So for those of you in here who maybe are a little bit nerdy, which is probably most of us in here, right? Okay. I decided to estimate and compare the total amount of the pre-flood Earth surface that could support human habitation so that we could compare it to the post-flood Earth that could support humans. And so today, roughly about 71% of the Earth's surface is covered by oceans and water, which means only 29% of land surface is land surface, globally. So we have 71% oceans, 29% land. Of that 29%, estimates that I found or that only 21% of that 29% is suitable for human habitation. So this sounds again like time to do the math, right? So if we have 29% of the Earth's total surface, that is land area, and we multiply that by 21%, so 21% of the 29% of the land mass that's habitable, you only end up with about 6.09% of the current surface of the Earth that's actually really suitable for human habitation. So today it doesn't seem like there's all that much surface area that we can live in. With so much of the Earth's surface being oceans, you can kind of start to see that. I mean, you can say, well, so much of this is ocean. We can't live out there, right? And with the high mountains and the deserts and some of these things that we see around the Earth today, just not being areas suitable. So today we look at the Earth's population is about 8.3 billion people. We all live in this approximately 6.09% of the Earth's surface. But the main takeaway here is that the pre-flood land surfaces would likely support much more human habitation. Again, maybe virtually all of the Earth could support human existence. So if you're thinking about just how many people the Earth can support, that's a widely varying figure depending on who you ask. Some will say we're already at the limit. Others would say that the Earth could support upwards of 50 or even 100 billion people. So there was a survey taken in 2004, and they looked back at 94 different limits to world population that were estimates that were compiled over estimates that were from the last few hundred years, actually back to even as early as 1679. And they found that these estimates by these so-called experts, they're always experts, until they're proven wrong, until they find out that what they predicted wasn't true, right? But they see estimated ranges of anything from 0.65 billion, which of course we're well above that, to as much as 98 billion. And of course, these much lower figures were from figures that were, earlier figures, closer to the earlier figures of like 1679, let's say. Of the last 125 years or so or less, most of the estimates have come out to be higher than that. And they took a median of all these estimates, basically median of all of them, and they came up with an estimate of 7.7 billion, which of course is a little bit below today's world population. Again, this is all guesses, so none of this is actually scientific. But of course, many factors would figure into increasing the estimates as we get closer and closer to current times, like technological advances in food production, let's say, or advances in housing and medicine and other factors. So we can only guess at this, but I thought it was sort of interesting just to look at that. So, but given the numbers for the pre-flood Earth, we see that there's maybe 70 to 85% of the Earth's surface that would have been land, and with this extensive vegetation and lack of extremely harsh areas. Again, we can only guess at this. I think it's interesting. I don't know how much there would have been, but since God commanded the humans to fill the Earth, I think it's likely that virtually all the land area was available and could have supported a much, much higher population than I think God was thinking in the future. Yes.
I mean, this is just amazing to me because this is kind of how I, in my own mind, how I kind of picture it, what's prior to the flood. Yeah. And our sins, as we see ourselves today, but to know the entire world was so denying God. Yeah. I mean, I can't fathom that.
Well, one of the things I want to bring up is see what the consequences of sin are. I mean, see how serious this is? I mean, this whole world is completely different. I mean, I think few people stop and contemplate or really think about it or really understand just how different the pre-flood and post-flood Earth was. Yeah, and it's because of sin. It's because mankind before the flood got so violent and so evil that God sought no other recourse than to wipe it out, basically, other than, thankfully, Noah and his wife and their 3 sons and their 3 wives. We wouldn't be here today. I mean, so these are things to really think about. But the bottom line here, again, it seems very likely that virtually all of the pre-flood land would have been available, and it would have provided abundant food for all of us, including the animals and, of course, the mammoths that we're talking about here.
Hey, Steve?
Yes.
I was just going to say that I've heard scientifically that there's evidence that the genetic pool was much greater than it is today.
Mm-hmm.
Scientists have allowed themselves to take it down to as few as 10 people. They won't say 8, but as few as 10 people,
Oh, yeah,
bottlenecking the genetics
Yeah.
from what we have today. So there
Oh,
may
yeah.
have been vast numbers more people on the earth pre-flood.
Oh yeah, we don't know. We again have to estimate that, but there could have been billions and billions of people before the flood. We don't know. I mean, we've seen estimates from millions to billions and billions. I mean, and to think about it in those terms, when you think there could have been, I mean, billions of people, and there was only Adam, or I'm sorry, Noah, was the only one found to be righteous. I mean, you can only imagine what the pre-flood Earth must have been like. I mean,
God didn't need Noah to start over. He could have created a new Adam and a new Eve. But I think, from my perspective, and some other conversations that I've had, to have a survivor tell the story and be able to, that's a warning.
Oh,
If
yeah.
you don't listen to that warning, like, society could have done the same thing with a new Adam and a new Eve and gone to sin right away. But with the warning of a flood and destruction of Earth and stuff like that,
it's
hope for
pretty
something greater.
sobering. Yeah, it really is.
God's so amazing.
That's pretty incredible. So getting back to this evidence again of abundant food and warm climate, again, I think these animals living prior to the flood, they would have had these arrangements we just talked about here, would have been ample food and an environment where they could have easily been able to feed themselves. And thus, I don't think we don't have the problem of having to explain these areas being above the Arctic Circle, being permanently frozen. Later on, we'll talk a little bit about the summer-fall deaths. Well, I think that is a non-factor now, because the seasons prior to the flood would have been completely different and much milder differences than it would have been post-flood. So with so much food, it explains how they would have been well-fed. Again, I think there would have been temperate climates across the whole Earth, no matter what the season was, and able to provide this food for them. And so again, here I think God would have provided ample supplies for these animals that He created, right? It just totally makes sense. The next explanation to be explained is the elevated burials. Regarding elevated burials during the flood, I think both prey and predator together would have also sought protection from a very grave enemy that they would have encountered. That would have been the rising waters. So from the rain that preceded the muddy hail, and also there would have been a lot of noxious gases involved here. So these larger animals, such as mammoths and other animals like rhinoceros and other larger animals, would have then rushed to higher ground. And they would have ran by and crushed a lot of smaller animals, I think, in the process. So I think this would have been expected, that these larger animals, and therefore much more mobile animals, could move much quicker, would have sought higher grounds, and explains why so many of them were found buried in elevated areas. And then regarding the formation of so much frozen muck, remember that the muck is made of fine sediments that would have been expected in the muddy rain and hail and ice that mixed with pulverized vegetation was ejected way up into the Earth's atmosphere, fell back down, and this soupy cold mixture, along with ripped up forests, would have flowed into valleys and other low areas and would smooth the topography into flat, low plateaus. And that's what we see when we dig down in through the permafrost in Siberia. You'll hit hard rock below that as you go down. And there are areas where that's higher and lower. So again, pre-flood, there would have been, there would have been, again, not any more, I think, than a mile of differences between the higher and the low points. But this explains, again, how this would be flat now as it would have filled in those valleys and low areas and smoothed out the topography to what it is now. There's low plateaus there. And of course, later this muck froze, preserving to this day the distinguished organic components that are found in it. And we're going to find out a little bit later on why it froze and how it stayed frozen. Next is the explanation for the special unique type of ice that we've talked about called rock ice. So remember, water that's in its liquid state absorbs air, but rock ice is very undersaturated with dissolved air. In other words, it contains little, if any, dissolved air in it. This is one factor that differentiates rock ice from the other characteristics of the three types of ice we discussed. And so why would this be? Why would this ice be so different without the dissolved air in it than the other three types of ice, the type 1, type 2, type 3? So some of it's solid ice, some of it's ice from snow and frozen lakes and things like that. But why would this water be different? Why would it not contain the large amounts of dissolved air? Does anybody have a guess?
It was in the atmosphere. It got ejected up into the atmosphere where there's less oxygen.
Nope, a little bit different. It's because it's actually a relatively simple question to answer. Before the flood, the subterranean waters in the subterranean chambers was completely sealed off from the atmosphere. In other words, you had the 60 miles of the crust, the waters above, the waters below. The waters that were below were completely sealed off from the air above. Therefore, they weren't exposed to the Earth's atmosphere, and they wouldn't have absorbed oxygen or air into that water. So again, this is a key component of this mysterious ice. So just as liquid water dissolves salt and sugar and many other solids, water also dissolves gases that come in contact with it. And again, all ice on Earth is saturated with air to a certain extent. However, ice in its ice form absorbs air very slowly, especially in the inner portion of ice. So that very little air would be absorbed as this muddy hail fell back down to Earth. So this water that exploded up out of the fountains of the Great Deep wouldn't have had much, if any, air in it. It really wouldn't have had any at the beginning, and would have frozen very quickly and fell back down without this air dissolved in it. Pretty interesting. So as the fountains of the Great Deep exploded up through the atmosphere, rapid and steady evaporation from the rising liquid forces gases away from instead of toward each of these rising particles. Therefore, when this water froze high in the atmosphere and even above, it would have had little dissolved air, but it would have had actually a lot of carbon dioxide. And both of these froze to become a mixture of water ice and frozen carbon dioxide, which is dry ice. So frozen carbon dioxide is dry ice. And so this explains why this ice is so different than the other of the three types of ice. None of the other theories about the frozen mammoths even approaches trying to explain this. But hydroplate theory has a simple explanation that makes complete sense. So as this unique hail fell to the surface of the Earth and it began to pile up in greater and greater depths, the weight of the topmost layers would start to crush or compress the lower ice and eventually seal off this lower ice from the air and just allowed it not to absorb any air at all, even over the coming centuries. And this is why Hertz, he was one of the ones that found the mammoth Beryskova, saw ice under Beryskova turn yellowish brown as the ice first contacted air and it reacted chemically with the air. The next feature to be explained is many of the animals having dirty lungs. And so this jetting fountains of the Great Deep produced extreme winds, and dirt would have filled the atmosphere with a lot of dust, especially in the hours before the rain. And this explains why some of these animals had a lot of dirt and dust in their respiratory systems. Remember one we talked about a couple weeks ago was a baby mammoth named Dima, and its entire digestive tract and respiratory tract contained silt and clay and small particles of gravel. And this falling back down to Earth also explains why high velocity dirt particles peppered and bombarded animals and even left shrapnel, or what Dr. Brown termed peppered tusks, on one side of these animals' tusks. So as this fell back down, it would have hit, the side that was facing up, and accounted for all these particles, these little pits and shrapnel that these tusks were found in. So regarding how temperatures could be 150 degrees below zero or lower to quickly and extremely rapidly freeze the mammoths, and froze them so fast that their stomach contents were preserved virtually instantly. We want to look into that just a little bit more too here, because this is pretty interesting as well. The Earth earlier mentioned that high up in the Earth's atmosphere, temperatures drop dramatically, and but the water that would have been ejected out of the Earth from the supercritical water below would have been extremely hot. So this supercritical water becomes supercritical. It's a fourth state of water, and it becomes supercritical when it reaches a temperature of 705 degrees Fahrenheit, but it also has to be under extreme high pressure. So high pressure of at least 3,200 pounds per square inch of pressure is required. And at that point, this water becomes a part gas and a part liquid, and contains tremendous amounts of energy. So it's extremely hot. So if this water was so hot, how could that water have frozen the mammoths? It was because it became very cold very rapidly as a result of the special circumstances that happened at the time of the bursting forth of the fountains of the Great Deep. So again, to fully understand how this occurred, I just want to briefly review supercritical water, what it is and how it becomes supercritical in the first place, and a little bit of its unusual properties. And we covered this earlier in class. And you may remember this chart, if you were here previously. And this chart shows you the 4 known states of water. So on the left side here, you see ice. Here on this side, you see water and its vapor or gas state. Up there, you see water in its liquid form. And then up here, you see where water becomes supercritical. So this chart represents that. So across the bottom, we see temperature. And as temperature rises, it goes left to right. And of course, pressure is shown on the left there. And of course, the higher you go, the higher the pressure is. So at atmospheric pressure, which is basically what we experience, on Earth, that's the amount of, basically the atmospheric pressure is the amount of weight pressing down on the air molecules. And as you go higher and higher, there's less and less weight, so air becomes less pressurized. And that's why the air becomes thinner as you go higher. But as you go underwater, for example, what happens is the deeper and deeper you go into water, the more pounds per square inch of pressure there is in the waters. We talked about that a couple weeks ago as well. And that's because there's so much weight above you. The water pressing down produces tremendous amounts of pressure. So that's kind of what this pressure is. So the pressure basically is a physical force, or the amount of force applied over the surface area of a particular, like water, or air. And it's measured in pounds per square inch, or PSI. And this pressure is key to understanding how water can become supercritical. So pressure, again, is also measured in something called bars of pressure. So a bar of pressure is basically a relative amount, so we can get an idea of how much pressure there is compared to what atmospheric pressure is, what we experience as being on the surface of the Earth. So that's atmospheric pressure. 1 bar now is basically 1.013 bars of pressure. So I'm not sure where the 0.13 comes from, but anyway, it's approximately 1 bar of pressure. So this gives a point of reference to start with. And, oh shoot, the bell. It always goes by too fast. So again, we're all familiar that water can be in 3 different forms, like solid, liquid, or gas. And we encounter these different forms basically on a daily basis. But we'll pick up here a little bit on this next week and talk a little bit more about this 4th state of water that we're not really familiar with because we don't encounter this. Okay, it takes special circumstances to have water go supercritical. But again, it's key in understanding how all this happens. So, thank you very much. Appreciate it. Any questions, let me know. And appreciate your attendance.